And welcome back, everyone, to another episode of Beyond the Forecast. I am Chief Meteorologist Michael Stevens, and today we're going to dive one more day into fire weather and fire danger awareness. And we are going to start off with a fun little experiment that you can do with the kiddos to show how fire suppression works. Essentially, we are going to explain to you the fire triangle and what happens when you take away a pillar of the fire triangle. And also a fun little experiment to show that, and basically what comes out of baking soda and vinegar and how that can be a fire suppressant. So we'll have that experiment for you coming up, and then we'll send it over to meteorologist Haley Fiaschetti, who will explain Doppler Radar, what it's used for and why it's so important. In fact, even when there are wildfires, we can actually see that on Doppler Radar. So there's more than just uses with rain and thunderstorms. There's a ton of uses with Doppler Radar, and she explains that for you coming up. And then it's also Friday, which means it is Viewer Question Friday, where you ask a question, we explain, maybe even have a little explainer video for you, and we try to answer some of those questions that we might not have covered so far in the show. But first, before we get into the show, let's kind of get through some of the beginning portions of the show and some fun facts for you. Today, this day in weather history, April 11th, 1965, severe thunderstorms in the Midwest spawned 51 tornadoes, killing 256 people and causing more than $200 million worth of damage. Now, Indiana, Ohio, and Michigan were the hardest hit in what they called the Palm Sunday tornado outbreak. So this day, man, that's 50 years ago now. Wow. Actually, 60 years. 50 years? 60 years. Quick math? Help me on this one. 30, 40, 50, 60 years ago. 60 years ago today was the Palm Sunday tornado outbreak. Man, that's crazy. 51 tornadoes. Trivia time. Now, trivia. Yesterday, we wanted to know what event is an intense rainfall over a short period of time. Is it flash flood, lots of rain, pooling, or swamped roads? It's flash flood. So that is essentially just inches upon inches of rain that can lead to standing water quickly because it drains or soaking of the ground just cannot keep up with the amount of rain that is falling. Flash flooding. And that's what you usually see when you get flash flood warnings. Today, we are asking, what is a bright spot on either side of the sun caused by light refraction through ice crystals? Now, we've told you about this in some previous episodes. Were you paying attention? Is it halos, sun circles, sun dogs, or bright lights? QR code right there. Hit that with your phone, takes you to a link, and you can put in your answer. But again, what is the bright spot on either side of the sun caused by light refraction through ice crystals? Is it halos, sun circles, sun dogs, or bright light? Weigh in. Now, viewer photo of the day. This is a really cool photo. Just a beautiful, serene photo sent in from Johnny Nicholson, brought to you by Great Rooms. And Johnny says, "Good morning from the Sioux Locks." Absolutely beautiful picture there, Johnny, and thank you for sending that in. And I'll answer. Good morning. Thank you to Great Rooms for sponsoring viewer photo of the day. Now, getting into our show, I take you into a fun experiment that you can do with the kiddos and explain the fire triangle and how we have to take a pillar away from the fire triangle to get rid of fire. We'll have all that coming up right after the break. And welcome back, everyone, to Beyond the Forecast. Now, today we are going to be doing a little fun experiment to show you the fire triangle. Now, the fire triangle is quite simply the three things, the three ingredients that make fire burn. You need oxygen, you need heat, and you need fuel. Now, if you were to take one of those things away, fire won't work. So when you have that triangle, think of like a fire extinguisher. A fire extinguisher is trying to get rid of one of those pillars to extinguish the fire. And fire extinguishers, there's about several different types. There's powder, there's water, there's CO2, and all of those things will do certain things to a fire to get rid of one of those pillars. Well, today we're going to run you through a fun little experiment, which does include fire. So kids, if you want to do this, make sure your parents are involved in running the experiment. But we're going to show you an experiment that basically shows you taking away one of those pillars to to erase fire. So what you'll need is a candle, preferably one of these little candles like this that you can sit on top. You'll need a glass bowl or a glass, which the candle can go in. And then you'll also need some baking soda. You'll also need some vinegar. And you'll also need something to sit the candle on. So I have a little bit of clay here that will sit in the glass and the candle can sit on it. So this will go inside the glass, like so. And then you will put baking soda around the clay piece or the centerpiece that you have the candle sitting on. Now what you really want to do is have enough baking soda in there that will take up probably about 1/4 of an inch from the bottom to the top. You don't want it over the centerpiece. You don't want the baking soda too high. You want it right around about 1/4 of an inch. Now you also want a glass dish that is going to be above the flame. And we'll explain why here shortly. So there you go. All right. So let's spread that around. I might have too much, but we'll figure it out. All right. So we got a little bit of baking soda in there, and you can see it's surrounding our little clay piece. Not above it, but around it. And when we put that down, we'll show you that on the close-up. What you're going to need now is the candle. And you want to set fire to your candle. So it is burning. And you want to make sure you can set it safely inside the glass so you can see it burning. Now, remember we were talking about fire extinguishers. Fire extinguishers are looking to take away that one pillar, or maybe two pillars, so fire will come to an end. So you have oxygen, you have heat, and you have fuel. Those three things combined create fire. Think of it like chemistry. Those things combine to create an element, and that element is fire. But an extinguisher, if you take one of those pillars away, fire goes out. So what we're doing here is we have baking soda surrounding our candle. Now, you want to take some vinegar, and you might want to take a glass if you have a big jug like me, so you can start pouring it around the edges. And you'll see what happens. We'll have it on close-up right here, and then we'll also show you from there. But what's pretty crazy is we're going to take away one of those pillars with just some vinegar and baking soda, not touching the candle. We'll show you. All right, so we'll pour some vinegar in this glass. Everybody always loves it at work when I use vinegar. So if you've ever used vinegar and baking soda before, you know there is a chemical reaction. That's how you make a volcano. It starts to erupt. So what's going to happen when I put in this vinegar into the baking soda? Well, let's find out, shall we? Do you see that? The flame was extinguished. Now, why is that? What does baking soda and vinegar give off? CO2. So it's robbing the candle of oxygen, one of the main pillars of the fire triangle. So what you did was you created a chemical reaction with vinegar and baking soda, creating CO2, which started to rise in the glass. And as the CO2 got above the flame ran out of oxygen and went out. So there you go. Now, you want to try to prove me wrong? Just take some, or you can also do this too. Show you just the difference. You see that? There's still some CO2, and the flame can't keep going. See that? So there's still some CO2 in the glass. Now, what you can do is do it again, put more baking soda in there, and then light another candle, and put water in there, what do you think will happen then? Is it going to extinguish the flame or is it not? Well, it's not going to extinguish the flame because water and baking soda do not have a chemical reaction. It is not giving anything off. So vinegar and baking soda gives off that CO2. If you were to try to use a different substance, you'd have to pour it right on, especially water. You'd have to pour it right on the flame, extinguishing another pillar to the fire triangle. So there you go. Pretty cool little experiment that you can do, creating your own little fire extinguisher. So that's what fire extinguishers do. They take away that pillar trying to put out the fire. So today we created CO2, which took away the oxygen for fire to continue to burn. Pretty cool. A little fun experiment for you. Again, kids, if you want to try this at home, you can, but make sure your parents are involved. Make sure they are there with the fire, the baking soda, and the vinegar, because sometimes baking soda and vinegar can get a little out of hand. But it is really cool to see the science working. So there you go. I'm Chief Meteorologist Michael Stevens for Beyond the Forecast. We'll have much more right after the break.
Welcome back to Beyond the Forecast. It's Meteorologist Haley Fiaschetti, and today I'm sitting with you guys to talk about Doppler Radar. So what is Doppler Radar? A few viewers have asked us whenever we say radar on air, what do we actually mean by that? And that's a great question. So when we say radar, we are talking about a piece of equipment that we get our information from. Normally, it's based at a National Weather Service station. So think of Gaylord, Grand Rapids, Marquette. They have this equipment called a radar, a Doppler radar, and that's where they're able to pick up on precipitation, where we can see rain, snow, freezing rain, as we've been quite familiar with the past couple of days. That's where we get our current conditions in the atmosphere. And Doppler radar is actually really important to us every single day. It's kind of our eyes and ears all across northern Michigan. We have such a big really area of where we get information from. So we need to see what's going on in Gaylord while we're here in Cadillac or in Traverse City or even in the Sioux. So that's what we use Doppler radar for. But how is it actually used? So it really works by transmitting radio waves from this machine. It's kind of a big globe, and it sends out these little waves into the atmosphere. And when it hits something, say rain or snow, some precipitation, it sends back a signal to the Doppler radar back at National Weather Service, letting us know that they are seeing something in the atmosphere. That's why sometimes you might notice birds getting picked up from the radars, or a lot of flies or mosquitoes when spring is happening or summer is happening and the great migration's happening. You're noticing it get picked up on the Doppler radars. But for us, we mainly use it for rain and snow. So when we see rain in the forecast, there's a radar out there that will start to send out radio waves and then sending us back information that it's seeing rain or snow. And that's how we use it. As the rain moves, the radar can also pick up it moving, which is why when we show you radar, we normally show it in around a 3 to 6 hour span. That's showing as that rain maybe has moved over from Wisconsin past Lake Michigan onto our Lake Michigan shoreline. We're able to show and kind of tell that story as the radar can pick it up. Now, radars have actually been used for quite some time. They actually started being used back in World War II. This is from when they were practicing with military information, trying to find actually aircrafts in the atmosphere as we were preparing to attack for the war. So they would use Doppler radar to pick up certain military information, military aircrafts, through these radio waves to send back to see where there were the enemies and where they could fight. They also noticed while this was happening that it could pick up storms incoming to some of the air bases that they were at, and that's when they started using it and changing it more to weather-based. It took a while for it to be accessible, though. Once it became more affordable for a lot of people, that's when radars were available for National Weather Service, and by the 1990s, the majority of the radars have actually covered America. So we do have a pretty good radar coverage when it comes to the United States because of the National Weather Service and radars that are put at Air Force bases or military bases across the region. But we are starting to see a shift now from Doppler radar to something even more advanced called phased array radars that will start to pop up and become more accessible in the recent years. And in the next couple weeks, we'll be diving into that further.
Thanks, Haley. Now, coming up next, it is Friday, so that means Viewer Question Friday. You ask a question, and we break it down for you. We'll have that coming up right after the break. And welcome back, everyone, to Beyond the Forecast. Now, at the top of the show, we told you it's Friday, which means it is Viewer Question Friday, where you write in some questions, and we try to answer what might be on your mind, whether it's as simple as rain to maybe the laws of physics. Whatever it is that's on your mind, send it in to us, and if we haven't covered it yet, we'll give you a quick answer. And today, viewer question came in asking about what is the difference between meteorological seasons and just the normal seasons as we know them. Well, the big difference is meteorological seasons are basically done from the National Weather Service for 30 days. So at the beginning of September to, say, the beginning of December. Those 30 days, or 60 days, 90 days, those 90 days, that season, from the 1st of September to the end of November, is meteorological fall. It's easier to keep track of everything falling straight 90 days rather than waiting for spring or fall or summer or winter to start at a certain time and date and then keep track of everything 90 days after that. It's much easier to start at the first of the month and go 90 days after. So that is the difference between meteorological seasons and normal seasons. But we did do a video on this, kind of explaining the seasons and how and why we see the seasons. Check it out.
Today we're going to talk to you about the autumnal equinox. Yeah, it sounds like a crazy big word, but that just means fall. It's our transition point, right? We have the autumnal equinox, fall, and then also spring, and then we have summer and also winter. So what happens, why this happens, let's break the name down first. Autumnal equinox. Now, autumnal, autumn, equinox, it's a little bit different. Equinox is when the plane of Earth passes the geometric center of the sun. So that means everyone from the north all the way to the south get the exact amount of daylight each day. Well, on autumnal equinox. So that means if you were to look at the Earth, which is pole to pole, tilted at 23.5 degrees, if you were to actually put it upright, that would be what essentially fall and spring are. But the Earth doesn't tilt up and back and forth and like that. Earth is stationary like this, 23.5 degrees. It doesn't rotate this way, it doesn't rotate down that way, it doesn't rotate up and down. It's just sitting like that. And as we spin, we revolve around the sun. So at the autumnal equinox, we're at the center, we're at the side of the sun. And then for us, as we continue to revolve around the sun, once we get to winter, we're faced away from the sun. And then we continue to go back. Spring, just like fall, everyone sees the exact amount of daylight. And then as we continue on, we're pointed directly at the sun. That's summer. And then we just continue to do it over and over and over. 4 seasons. So that is the autumnal equinox explanation. And I really just broke down everything I'm going to tell you about with that explanation. So Earth is tilted at 23.5 degrees and orbits the sun. And as we orbit the sun, 90 days, we're in fall. 90 days, we're tilted away from the sun, so we're in winter. 90 days, we're again in spring.
So there you go. And you might recall John briefly hit on just a little bit of our seasons and why we see them a little last week, I believe it was, in an episode of Beyond the Forecast. And if you want to catch up on episodes or pieces of Beyond the Forecast, you can head to the 910 News YouTube channel or also the 910 News website and click on Beyond the Forecast, where we have everything laid out there for you, whether it's segments or full-on episodes. So thank you guys for joining us again for Beyond the Forecast, especially this week as we highlighted fire weather, fire danger awareness, and next week is going to be a free-for-all week where we're talking about anything and everything that is weather and science. So thank you to meteorologist John Gross, as well as meteorologist Haley Fiaschetti. I am Chief Meteorologist Michael Stevens. Thank you for joining us. Be good, stay safe, take care, and we'll see you guys next week.